Good day, colleagues. I'm Busiwa Manchu. Once again, we are going to do paper 2 memo discussion, the paper that they wrote on Monday. I hope you have marked so that you are able to moderate one another. Colleagues, let us ensure that we mark strictly according to the memo and we penalize where possible, where we are supposed to penalize, so that we prepare our learners to write the correct things at the end of the year. Thank you very much. Now let us start with our memo discussion, colleagues. In question 1, colleagues, the answers are exactly as they are in your memorandum. Kindly mark exactly as it is. There are no 2 possible answers. There's only 1 possible answer, which is in the memorandum. Thank you. Now let us go to question 2. In question 2, learners were asked that the statement says the letters A to G in the table below represent 7 organic compounds. And those are the given organic compounds. And then the first question there was, write down the letter or letters only that represent the following. A letter may be used more than once. For 1 mark, the learner had to write a letter that represents an unsaturated hydrocarbon. And that letter that was expected is A, so it's 1 mark. Colleagues, don't forget, you just put the tick next to the letter and then you transfer the marks to the right-hand side of the script of the learner, that 1 mark. And then the next question was, the letter that represents a compound with a carbonyl group as a functional group. And the answer there is B. It's a tick and then 1 mark to the right-hand side. Then the next question was a letter that represents a ketone, and that letter is also B. It's 1 mark. And then the next question, letters that represent 2 compounds that are functional isomers. And for those 2 letters, colleagues, as you can see, it's 1 mark. So those 2 letters are C and D. In other words, both of them must be correct for the learner to get a mark. And then the next question, the letter that represents the product formed during the hydrogenation of compound A. And that letter is G, and it's also 1 mark. And then let us move to question 2.2 there. For compound C, write down the name of the homologous series to which it belongs. And the name of that homologous series is esters. So when the learner writes ester, it's 1 mark. And then the next question, write down the IUPAC name of the alcohol used in the production of compound C. And that alcohol is methanol. So it's 1 mark for methanol. And then 2.3, in 2.3 there, write down the IUPAC name of compound C for 2 marks. The IUPAC name of compound C is methyl ethanoate. 1 mark for methyl, 1 mark for ethanoate. So say for instance the learner writes ethyl ethanoate. The learner will lose 1 mark for the first one and then get the 1 mark for ethanoate. Then 2.3.2, the IUPAC name of compound D. The IUPAC name of compound D is propanoic acid. And colleagues, bear in mind, the word acid there is important. It's not just propanoic. It is propanoic acid for 1 mark. And then the IUPAC name of compound G. The IUPAC name of compound G there, it is pentane. And it is important, colleagues, to emphasize to the learners that the spelling must be correct, because sometimes learners write after the T there's a Y and then there's a and E. We're not sure whether it's pentine or pentane. So if it's like that, please do not give a mark there. We must be able to pronounce it as pentane, not pentine. Now, 2.4, write down the structural formula of a positional isomer of compound A. And that positional isomer of compound A is given in the memo, where the double bond is between carbon 1 and carbon 2. So the way you mark this one, it's 1 mark for the functional group. In other words, the double bond between 2 carbon atoms and the correct number of bonds around those carbon atoms. It's 1 mark. And then for the rest of the molecule, including the functional group, is the 2nd mark. In other words, say for instance the learner writes the double bond between carbon 2 and carbon 3. If the double bond is there and there are correct number of bonds around those carbon atoms, then the learner will only get 1 mark for the functional group, because now the rest of the molecule will be incorrect. Colleagues, take note of the notes that are in boxes. If more than 1 functional group is given, then the learner will get 0. For example, if there are 2 double bonds in this molecule, then the learner will get a 0. You don't mark one of them, because now there are 2 functional groups, then it is 0. And then if the learner writes a condensed or a semi-structural formula, the learner will only get the 1 mark for the functional group. In other words, you still give 1 mark for the functional group, 1 mark for the rest of the molecule, and then you take 1 of the marks because the learner did not follow instructions. And then if the learner writes a molecular formula, it's 0. No mark even for the functional group, because you won't see the functional group there in the structure. And then question 2.4.2, write down the structural formula of compound F. The structural formula of compound F there, it is given as follows. It's 1 mark for the functional group with the correct number of bonds, and then 1 mark for the rest of the molecule. In other words, if, for example, in the carbon, this C double bond O here, that is that one of the functional group, if the learner includes an H there in that carbon, then it means the functional group now becomes incorrect. Then the learner will get a 0. For example, it happens that sometimes the learners don't write the correct functional group. For example, the learner will write the correct number of carbon atoms and the correct number of the correct functional group, but unfortunately the learner includes the H there. It means the functional group automatically is incorrect. Then the learner must get 0 out of 2, because we start with the functional group. If the functional group is incorrect, then the rest of the molecule now becomes incorrect. Now, when we go back to the memo, it's 1 mark for the functional group and then 1 mark for the whole molecule that is correct. In the notes again, if more than 1 functional group is given, it's 0. And then if a condensed or semi-structural formula is given, the learner can get a maximum of 1 out of 2. And then if a molecular formula is given, it is 0. Now, let us move to question 3. In question 3 there, the table below shows the boiling points of 6 organic compounds represented by the letters A to F. And those organic compounds are represented there in the table. Now, 3.1 says, consider compounds A to C. 3.1.1, what is the physical state? The learner must choose either solid, liquid, or gas of propane at 45 degrees Celsius. Now, the answer that is expected there, it is a gas. So 1 mark for the gas, and you put a tick there. Now, colleagues, let me go back to question 2. Remember, for each question, colleagues, you put the ticks and then you put the total on the right-hand side. Now, after everything is done in question 2. You would combine the marks that you put on the right hand side, and then at the top of the question where there is a question 2, you will put the marks on the left hand side, just to the left of the question there, which is question 2. Okay, colleagues, now let's move on to question 3. The first mark there was for guess, which is 1 mark. And then the next question, write down the general formula of the homologous series to which these compounds belong. Remember, it was compounds A to C. Now, the homologous series to which those compounds belong, it is, it looks like I write down the general formula of the homologous series to which these compounds belong. So that general formula is CnH2n plus 2, 1 mark there. And that's the only answer, colleagues. And then 3.1.3, what is the trend in boiling points from compound A to compound C? And then write down increases or decreases and fully explain this trend for 4 marks. Now, when we mark that questions, colleagues, we must remember they must fully explain. So for the learners to get the marks of the explanations, the learners must first answer the question. So the answer there is increases for 1 mark. And then if the learner writes increases, then you are able to mark the reasons. That is the meaning of this symbol here, which is negative marking. In other words, if the learner does not write increases as the answer, then the marks for the reasons are automatically forfeited. And colleagues, please, let us ensure that we explain to the learners that they need to answer the question. Because if the answer is incorrect, or if there is no answer at all, we are not able to mark the reason. So they must give the answer. It doesn't matter whether it's at the beginning or at the end after the reasons, as long as the answer is there, because the marker must first look for the answer, which is increases, and then the marker will be able to mark the reasons. Now, the first part of the reason, the learner must explain according to the structure. The learner must say the chain length increases, or the molecular size increases, or the molecular structure increases, the molecular mass increases, or the surface area increases for 1 mark of the reason. Then for the second mark of the reason, the learner must explain according to intermolecular forces. Then increase in strength of intermolecular forces, it's 1 mark, or there is an increase in strength of van der Waals forces, 1 mark, or there is an increase in strength of London forces, it's 1 mark. And then the last mark there, they explain according to the energy. The learner must say more energy is needed to overcome the intermolecular forces or to break the intermolecular forces, or more energy is needed to overcome the van der Waals forces, or more energy is needed to overcome dispersion forces or London forces. And colleagues, please, let us ensure that our learners know that it is to overcome the intermolecular forces, not the bonds. And then 3.2, the boiling points of compounds C and E are compared. Fully explain the difference in boiling points by referring to the type of intermolecular forces present in each of these compounds. Now for 3.2 there, the answers that are expected for 3 marks, the learner, the first answer must say, between propane molecules there are London forces, or between molecules of compound C there are London forces for 1 mark, or there are dispersion forces or induced dipole forces. And then for the second mark, the learner must explain according to ethanol. Between molecules of ethanol, there are London forces, dispersion forces, induced dipole forces, and hydrogen bonds. Take care, colleagues. The underlined words are the ones that you are marking. So the learner must say between ethanol or between molecules of E, there are hydrogen bonds. And please, colleagues, it is important for the learner to say which one has hydrogen bonds. The learner may not say one has London forces and the other has hydrogen bonds, because actually both of them do have London forces, but in addition, ethanol will have hydrogen bonds. And then for the third mark, the learner must say hydrogen bonds between alcohol molecules are stronger than those, just say hydrogen bonds between alcohol molecules are stronger, meaning the learner is saying the London forces are weaker in propane. Or the learner can say hydrogen bonds or more energy is needed to overcome the hydrogen bonds in alcohol molecules than the London forces, or the dispersion forces, or the induced dipole forces. Or instead of saying, writing those steps in 3 different steps, the learner can just make one statement where all these 3 bullets are catered for in one. The learner can say, between propane molecules are weak London forces for 1 mark, and then between ethanol molecules are strong hydrogen bonds. So the 2 marks at the end, the 1 mark is for hydrogen bond, and then the other mark is for saying that hydrogen bonds are strong. Then the learner will get those 3 marks. And then 3.3 there. How will the vapor pressure of compound E compare to that of compound F? Write down higher than, lower than, or equal to, and then give a reason for the answer by referring to the boiling points of the compounds. So the learner there was asked about the vapor pressure of compound E compared to that of F. So the vapor pressure of compound E is higher than the one of compound F. So the learner must say higher than first before you are able to mark the reason. Then after saying higher than, then the learner must say it is due to the fact that E has a lower boiling point. And that is all of question 3. And then you just add the marks again and move the total to the next to question 3. And then in question 4, it is organic reactions. Propane is used as fuel in heating appliances, cooking equipment, and vehicles. It burns in air to release large amounts of energy. 4.1. Using molecular formulae, write down a balanced equation for the complete combustion of propane in oxygen for 3 marks. Now for that one, the learner must write this balanced equation. Remember, for C3H8 and O2, that is on the left hand side as reactants, it's 1 mark. And then for CO2 and H2O on the right hand side, it's a 2nd mark. And then the 3rd mark is for balancing. In other words, putting the 2 next to C3H8, the 10 next to oxygen, the 6 next to carbon dioxide, and the 8 next to water. It will be 3 marks. That is, will be the 3rd mark is for balancing. Now it's 1 mark for the reactants, 1 mark for the products, and 1 mark for balancing. Ignore double arrows. So even if the learner includes double arrows there, you still give full marks. And then there is marking rule 6.3.10, whereby for you to be able to mark the reactants, there must be the arrow there on the right hand side of the reactants. And for you to be able to mark the products, there must be an arrow to the left hand side of the reactants. Now, colleagues, we know that actually we have the coefficients where the ones that you use for balancing can be less than the ones that are given there. So if the learner writes C3H8 plus oxygen and gives CO2 plus H2O, there and the learner has 3 CO2 there, and the learner will have 4 of that. It means the learner can have 5 of that. So instead of writing 2 here and a 10 and a 6 and a 4, the learner can write this simplest form. In other words, what I'm saying to you is we accept any correct multiples of these numbers that are balancing here. And then the next question. The flow diagram below shows how propane can be used as starting material in the preparation of other compounds. Propane undergoes reaction A to form compound X with that condensed structural formula, and then that compound X undergoes reaction B in the presence of hydrogen bromide to form a haloalkane, and that haloalkane undergoes reaction C to form an alcohol. Now for 4.2, write down the type of reaction. Choose between addition, substitution, or elimination, represented by 4.2.1. It is A there. So A there for 1 mark, it is elimination. 1 mark. And then 4.2.2 for compound B there. Type of reaction for compound B, it is addition reaction, and the type of reaction for compound C there in 4.2.3, it is substitution reaction. Now for 4.3, in reaction B, compound X is converted to a haloalkane. Write down the IUPAC name of compound X for 1 mark. So the IUPAC name of compound X is prop-1-ene, or 1-propene, or just propene. Colleagues, just ensure that the learner writes all the required hyphens there. For a missing hyphen, even if one of the hyphens is missing, it means the 1 mark is gone. So between the name and the number must be a hyphen. And then 4.3.2, write down the balanced equation for the formation of the Mayer product in reaction B using structural formulae for 4 marks. Now, the learner must include all the bonds, because it is said that they must use structural formulae. So if there is a double bond there between carbon 1 and carbon 2, and all the hydrogens are correct, and all the bonds are shown, it's 1 mark for the prop-1-ene. And for HBr, it's the 2nd mark. And then for the products, if the Br is connected to the middle carbon and all the bonds of that middle carbon are shown correctly, then there's 1 mark for the functional group. And then if the rest of the molecule is correct, including the functional group, then you give the 2nd mark. Now, in the notes, it is said, accept HBr as the condensed structure. So even if the learner does not include the bond there for HBr, it's still, the learner will still get 1 mark. Ignore the double arrows. And then any additional reactants or products, the learner, you must penalize 1 mark. So the learner can get a maximum of 3 out of 4. Maximum, colleagues, meaning it depends on how many marks the learner already has. If everything is correct, you will mark everything and give 4 marks. And then because the learner did not use structural formulae but used a condensed or semi-structural formula, you take any of these marks, then the learner will get 3 out of 4. In other words, say for instance, in the reactant, instead of HBr, the learner said H2O. Then the learner will still get the mark for the prop-1-ene. The learner will lose the mark for HBr because the learner said H2O. And maybe here in the middle, the learner will write OH. Then it means the learner will lose both the marks of the products, then the learner had 1 mark of the prop 1 in. But because the learner used condensed or semi-structural formula, you take that 1 mark that you gave. It means the learner will get 0 out of 4. That's the meaning of maximum. And then if everything, or if there's an additional reactant or a product, then you penalize 1 mark in any of the marks that you have given. If everything is correct but no arrow in the equation, you still give all the marks and then you take 1 of the marks because there is no arrow. Then the learner can get a maximum of 3 out of 4. And then if only products are given as the answer, then the learner will get 2 out of 4. So a maximum of 2 out of 4, meaning if the BR is correct and the rest of the molecule is correct, the learner can get the 2 marks of the product. And then if only the organic reactant is given, then the learner will get that 1 mark of the organic reactant. And then question 4.4. Reaction C takes place in the presence of a strong base. Write down 2 reaction conditions needed for 2 marks. Now the reaction conditions there needed, the learner must say that strong base is dilute. So the word dilute is important. And then the second condition is there must be mild heat. The learner can just say there must be heat to get the mark. The mild there, it's in brackets, meaning the learner need not give that mild. So for heat, it's 1 mark, and for dilute is the 2nd mark. Even if the learner says sodium hydroxide, the learner must say dilute sodium hydroxide. So the word dilute is the one that carries a mark. And then 4.2, write down the IUPAC name of the alcohol produced in this reaction. Now the IUPAC name of the alcohol there is propan-2-ol or 2-propanol. Now you mark propanol for 1 mark and then the 2 there with the correct hyphens for the 2nd mark. Meaning, for you to be able to give the mark of the 2 there, which is the one of propan-2-ol, the propanol must be correct first. In other words, it must be an alcohol first for you to be able to give the 2 there. Let me make an example. If the learner says hexan-2-ol, because it is an alcohol, the learner will lose the mark for hexanol, but will get the mark for the 2 because it is an alcohol. But for example, if the learner says propan-2-one, the learner will get 0 because one is a ketone. Therefore, the 2 the learner will lose because it's not an alcohol. The learner will get 0. In other words, if the learner just writes propanol, the learner will get 1 mark for propanol and lose the 2nd mark because there's no 2 there. And then 4.5, during a reaction, the alcohol in question 4.4.2 is converted to compound X. Write down the formula of the inorganic reactant that is needed. Bear in mind, colleagues, in capital letters, it is said formula. So the answer there that is expected is H2SO4 or H3PO4, not the name. And if the learner writes the name there, you penalize, the learner gets no mark. Then the total there is 16. And then for question 5, learners use the reaction between sodium carbonate of and a 0.1 mole per cubic decimeter sulfuric acid solution to investigate the reaction rate. They pour 150 cubic centimeters of the sulfuric acid solution into a beaker and add enough sodium carbonate powder to neutralize the acid. The temperature of the reaction mixture is kept at 0 degrees Celsius. The balance equation for the reaction is as given in the paper. 5.1 for 2 marks, define the term reaction rate in words. The expected answer there is the change in concentration of reactants or products per unit time. It's 1 mark for the change in concentration, and then it's 1 mark for per unit time. Or the learner can say the change in number of moles for 1 mark per unit time, the second mark. Or the change in mass for 1 mark per unit time. It is either for the reactants or the products. So the word change applies in all of them. Change in concentration, change in number of moles, or change in mass for 1 mark per unit time. It is the second mark there. So the 2 marks are separate. And then 5.2, graph A, which is represented by a solid line there in the graph, shows the volume of carbon dioxide gas formed as a function of time. And then the graph is given. 5.2, how long in seconds did the reaction represented by graph A take to reach equilibrium? How long did the reaction represented by graph A take to reach equilibrium? Because the words in second are already part of the question, then the learner can just say 100 without even including the units, because the units are already included in the question. So if the learner just says 100, it's 1 mark, or 100 seconds, but it cannot be 100 minutes. So if the learner says 100 minutes, it means the answer now becomes incorrect. And then 5.3, how does the reaction rate of the reaction represented by graph A at t is equal to 5 seconds compared to that at t is equal to 25 seconds? Write down higher than, lower than, or equal to, and then use the collision theory to explain the answer for 3 marks. 5.3 there, the learner must say higher than to get the first mark, and then to get the 2 marks of the reason, this answer must be higher than. If the learner says lower than, then it's 0 out of 3. Then for the first mark of the reason, initially the concentration of the acid is high for 1 mark, or initially there are more particles per unit volume. That's the first mark. And then there will be more effective collisions per unit time. Colleagues, bear in mind all the underlying words are important. For example, if the learner just says more effective collisions, then the mark is gone, because the words per unit time or per second or per minute, any indication of per unit time, then the mark will be gone if those per unit time are not there. And then 5.4, calculate the maximum volume of carbon dioxide gas in cubic decimeters that can be produced by this reaction at standard temperature and pressure. Now, the marking criteria there, that is the box in your marking guideline. For the first mark, you give the mark for the correct formula. Whether the learner says C is equal to N over V, or N is equal to CV, or V is equal to N over C, it doesn't matter, but it must be the correct version of this formula. So for C is equal to N over V, it's 1 mark. And then for substitution of 0,1 and 0,15, it's 1 mark. So for substitution of 0,1 as concentration and the substitution of 0,15 as the volume, it's 1 mark. and then the number of moles there. Colleagues, please rectify this. When you multiply 0,1 with 0,15, it will give you 0,015. Please rectify the number of moles there. It is 0,015, not 0,15. But bear in mind, there's no mark for those number of moles of the acid. And then the learner goes back to the balance equation. To get the number of moles of carbon dioxide, they are exactly equal to the number of moles of sulfuric acid. Therefore, the number of moles of carbon dioxide will be 0,015 to get this mark here. So even if the learner lost the substitution mark because something is incorrect, and then got incorrect number of moles of the acid, but if the learner says the number of moles of the acid are equal to the number of moles of carbon dioxide, then the learner will get the mark of the number of moles for the correct transference there. And then that is the third mark for the mole ratio. Number of moles of carbon dioxide equals number of moles of sulfuric acid. Then for the fourth mark, the learner must substitute the number of moles of carbon dioxide and the molar volume of gases there. Remember, it was set at STP. Now, learner uses N is equal to V over Vm, and then substituting 0,015. Colleagues, please rectify this number of moles as well. It is 0,015, and then substituting the molar volume as 22,4 correctly for the two substitutions here, it's 1 mark, and then the final answer must definitely be 0,34 cubic decimeters or 0,336 cubic decimeters. But colleagues, remember the words in cubic decimeters was already there in the question. So even if the learner did not say cubic decimeters, just says 0,34, give the learner that mark. So remember again, instruction says they must round off their final answers to a minimum of 2 decimal places. So it can be 2 or more, but not less than 2. So if it is 0,3, it is incorrect, but it can be 0,34 or 0,336. And then question 5.5, the same reaction is now repeated using the same mass of sodium carbonate and the same volume of 0,1 mole per cubic decimeter sulfuric acid. The volume of carbon dioxide formed as a function of time is represented by graph B above. And then write down 2 possible changes that could have been made to the reaction mixture there. When you have a look there, for the change, there is graph B showing that the rate has decreased. Therefore, the 2 possibilities there could be the temperature was lowered or sodium carbonate chunks were used. This answer, sodium carbonate chunks, any indication that the sodium carbonate that was used has a larger, has a smaller surface area, then the answer there would be correct. So sodium carbonate chunks are there. Now, colleagues, remember, the learner cannot say, for example, the concentration of sulfuric acid was decreased, because in the question already they were told that it is 0,1 mole per cubic decimeter of sulfuric acid, which is the same as the one they used originally. So it shows that the concentration of sulfuric acid is kept constant. So those are the only 2 possible answers there. Now, let us move to question 6. In question 6, 12 moles of sulfur trioxide gas is sealed in an empty 2 cubic decimeter container at 700 Kelvin. It decomposes into sulfur dioxide gas and oxygen gas, and equilibrium is reached at 700 Kelvin according to the following balanced equation. The balanced equation is given and the forward reaction is endothermic. Define the term reversible reaction for 2 marks. A reversible reaction is a reaction where products can be changed back to reactants. Take note on your memoranda. The 2 marks are at the end, meaning the word products changed back to reactants must be there for the learner to get the 2 marks. If anything is incorrect there, the learner will get 0. The marks are not separated, therefore it means it is 2 or 0. If anything is incorrect, it's 0. There's no 1 mark there. And then 6.2, if 5 moles of oxygen are present at equilibrium, calculate the equilibrium constant for this reaction at 700 Kelvin for 7 marks. Now the criteria for marking the first option there when the learner uses moles first, the first mark goes to the change in number of moles, where it is equilibrium moles of oxygen minus initial moles of oxygen. And then the second mark goes to the mole ratio there, where the moles of sulfur dioxide and sulfur trioxide are twice those of oxygen. And then the third mark will go to the equilibrium moles of sulfur trioxide, remembering that sulfur trioxide is a reactant. So equilibrium moles will be initial moles minus the change. And then the equilibrium moles of sulfur dioxide, because it is a product, will be initial moles plus the change moles. When both of them are correct, it is the third mark. And then for the fourth mark is for dividing by the volume, dividing the equilibrium moles by the volume. And then the fifth mark is for the correct Kc expression. Now, mark number 6 is for the substitutions of the equilibrium concentrations that the learner got, the substitution of them correctly into the Kc expression. And then the final mark, the answer must definitely be 62.5 for the learner to get the answer there. So if the learner uses this method, remember, they were told that at equilibrium there are 5 moles of oxygen. So for getting these moles of oxygen there, the change, for saying that the change in moles is 5, which is the equilibrium moles, minus 0, which is the initial moles, then the learner gets 1 mark there. So equilibrium moles minus initial moles, giving you the moles of oxygen, is 1 mark. And then the second mark is for the mole ratio. The moles of sulfur dioxide and sulfur trioxide are twice those of oxygen. It is the mark for the mole ratio. And then the third mark, the initial moles of sulfur trioxide minus the change, giving you the equilibrium moles. And then the initial moles of sulfur dioxide plus the change in moles, giving you the equilibrium moles of sulfur dioxide there. If these 2 are correct, the learner will get that 1 mark. And then for dividing the equilibrium moles by 2 there, all of the equilibrium moles by 2, the learner will get the 4th mark. And then for the correct Kc expression, colleagues, please include the square there for sulfur trioxide. It is Kc is equal to the square brackets of sulfur dioxide squared multiplied by the concentration of oxygen divided by the concentration of sulfur trioxide squared. So there must be a squared there. And colleagues, for you to give the mark for the Kc expression, the learner must use square brackets, not round brackets. It is there in the criteria. Correct Kc expression and formulae in square brackets, because remember, it is the concentrations. And then for substituting correctly the equilibrium moles that the learner has calculated and squaring those of sulfur dioxide and sulfur trioxide, it's 1 mark. And then the final answer there must be 62.5. Now, if the learner does not write the KC expression, but substitute the concentrations correctly and the answer is correct, the learner can get a maximum of 6 out of 7, meaning the learner will only lose the mark for the KC expression. But if the substitutions are incorrect, it means the learner can get a maximum of those marks that he or she obtained in the table there, which might be 4 marks. And then if a wrong KC expression is used, then the learner will lose the KC expression mark, will lose the substitution mark because the KC expression is wrong. It means the substitution will be wrong, and will lose the mark of the final answer. Then the learner can get a maximum of 4 out of 7, which is the ones that he got at the table. When we say wrong KC expressions, colleagues, we don't say if the learner used round brackets there. We say, for example, if the learner swapped the reactants and the products, for example, say the concentration of SO3 squared divided by the concentration of SO2 squared multiplied by the concentration of oxygen. That is a wrong KC expression. But if, for example, the learner used the round brackets, but everything else is correct, then the learner will only lose the mark for the KC expression. If the learner does not use the moles there, the learner can go to the second option. In the second option there, we give a mark when the learner divided the initial moles of SO3 and the equilibrium moles of O2 by 2. And then the second mark, it will be the change in oxygen concentration, which is equilibrium concentration minus initial concentration. And then the third mark will be the use of the mole ratio, which is 2 to 2 to 1. And then the fourth mark there will be if equilibrium concentration is initial minus the change of sulfur trioxide, and equilibrium concentration of sulfur dioxide is initial plus the change. If both of them are correct, it is the fourth mark. The fifth mark is for the KC expression. The sixth mark is for substitution of concentration into the KC expression, and the final answer there must be 62,5 there. So what we are saying here, the first mark, remember this was 12, so for dividing the 12 by 2 to give the 6, and for dividing the 5 there by 2 to get the 2,5. So if you have 6 moles, initial concentration of SO3 there as 6, and the equilibrium concentration of oxygen there as 2,5, for both of these, it's 1 mark for the dividing by 2. And then the second mark, if the change in moles of oxygen is equal to the equilibrium concentration minus the initial concentration there, is the second mark. And then the ratio mark there, if the ratio of sulfur dioxide and sulfur trioxide is twice that of oxygen, it is the third mark there. And then the fourth mark there would be for KC expression. The fourth mark there would be for equilibrium concentration of SO3 and SO2, where the one of SO3, its initial concentration minus change, and then for SO2, its initial concentration plus change. If those are correct, you get the fourth mark there. And then the fifth mark is for the correct KC expression. Please include the squared again for SO3, concentration of SO3. And then for the correct substitutions of the concentrations there is the sixth mark, and then the seventh mark there is for the correct answer there. Also here, if there is no KC expression, you still give the other marks. The learner will just lose 1 mark for the KC expression, then can get a maximum of 6 out of 7 marks. If the wrong KC expression is used, then the only marks that the learner will get are the ones in the table. Then the learner can get a maximum of 4 out of 7. Then let's move to question 6.3. The graph below shows the changes in the rate of reaction over 7 minutes from the time that the 12 moles of sulfur dioxide gas were sealed in the container. 6.3.1, write down the balanced equation for the reaction that is represented by the broken line. Bear in mind, it is set balanced equation for 1 mark. Therefore, the answer there that is expected there, it is oxygen plus 2SO2 giving us 2SO3. The phases may be ignored, but the equation must be balanced. And your reactants must be sulfur dioxide and oxygen. Your product must be sulfur trioxide, and everything balanced for 1 mark. 6.3.2, give a reason for the decrease in reaction rate represented by the solid line between time is equal to 0 minutes and time is equal to 2 minutes for 1 mark. The answer expected there, it is due to the decrease in concentration. We know that it is the decrease in concentration of sulfur trioxide. As long as the learner says decrease in concentration is 1 mark. And then 6.3.3, state the change that was made to the equilibrium mixture at t is equal to 4 minutes, and then fully explain how you arrived to the answer. So the learner must first state the change and then explain for 3 marks. 6.3.4 there, the answer expected there, it is the temperature was increased, or the temperature increases for 1 mark. Then if the learner does not say temperature increases, it means it's 0 there because there's negative marking. Then for the first reason, the rate at t is equal to 4 minutes, the rate of both the forward and the reverse reactions increases for 1 mark. Then the rate of the forward reaction, of the forward endothermic reaction increases more than the one of the reverse reaction, or the forward endothermic reaction is favored for the 2nd mark of the reason. And then for the last mark, increase in temperature favors an endothermic reaction. So these are the 3 marks. Any of these 3, when the learner writes any of the 3, the learner will get the mark. So each bullet has its own mark. But please, colleagues, make sure that the learner first answers temperature increases. If this is not there, or if that is incorrect, then it's 0 out of 4. And then question 6.3.4, how does the value of the equilibrium constant for the reaction at t is equal to 5 minutes compare to that at t is equal to 2 minutes? Write down greater than, smaller than, or equal to for 1 mark there. And the answer that is expected there, it's greater than, which is 1 mark. And then 6.3.5, explain the answer to question 6.3.4. Since this explanation is for the answer in 6.3.4, then it means if the answer of 6.3.4 is incorrect, automatically the 6.3.5 is incorrect. You don't even read those answers because there is negative marking from 634 to 635. The expected answer there are, answers there are, at t is equal to 4 minutes, the temperature was increased and the forward reaction was favored for 1 mark. Or increase in temperature favors the forward endothermic reaction. Therefore, the concentration of the products increases and the concentration of the reactants decreases for the 2nd mark. Then that gives you 2 marks there. That brings us to the end of question 6. Before we go to question 7, colleagues, let us take a 10-minute break. Now it is 10 o'clock, so it means we are going to continue at 10 past 10. See you then. Thank you very much.